I'm Kris Balkcom, Extension Peanut Specialist for Auburn University. I'm going to be talking to you today about some new planter technology. We did a lot of work here with precision planting. They have a new metering system, which is a V-Drive. This is a project that was supported by the National Peanut Board. We check off dollars for them. Something that has been lacking in peanuts way over the years. We've had the same vacuum metering technology from John Deere since the early 1990s. So now we've moved into a more advanced metering system, which you can see here that I'm holding in my hand, changing out the hopper units on your traditional planter, doing away with all the shafts, sprockets, and chains, going to an electric motor. The difference is, we're looking at the pros and the cons. So this new system works very well for corn, beans, cotton. A little bit different for peanuts, mainly due to the seed size of peanuts and the amount of volume that we plant per acre. When you're looking at peanuts that have a seed size of 575, 600 in a pound, and you're planting 130, 40, 50 pounds to the acre of them, it's a little bit more challenging to get that through one planter unit compared to the traditional planter. As you can see here is the traditional type planter and John Deere meter. You can see here we have a extremely larger disc for the vacuum than we do here for the V-Drive. So this is turning a lot slower to get out the same amount of peanut. This is turning a lot faster. Speed's not the problem for that to turn to get the volume out. It's the flow through these units. As you see here, we have the hole going down to the seed tube, which is what we found and measured is about 3/4 of an inch wider and an inch longer than what we have here through this V-Drive system right here. Now, so what we did was we set up a test with two different seed sizes with different planting speeds, 4, 5, and 6 miles an hour with these two different seed sizes. The seed sizes is 600 seed in a pound and 1,036 in a pound. And we could see a good bit of difference between these as we did this research. One thing I want to show is just like with this technology we have here, that same electronic eye that's on your planter would read and develop, give information to the planter monitor, which is full of information. But also just to show the accuracy, because one thing what we found with that was it really doing what it was telling us it was doing, or was that a false reading? So planting at 6 seed at 4 miles an hour with Tough Runner 511s, which was a seed count of 600 per pound, you can see it was pretty uniform. You can see a little dot here, which was a gap in one of the rows, one right here close to the end, one here, and one here. But pretty consistent throughout that planting plot there. Now as you look and see, as we kept the same variety with that same seed size, kept it at 6 seed per foot, we went up to 6 miles an hour planting. Look at the inconsistencies there that the monitor was picking up and telling us and alarming us that it was not planting properly. And so we was like, well, is that really true or not? So we wanted to look at that, test its accuracy, and see what we found. What we found through that doing this research, that it was accurate. As you can see here, look at our stand counts to where we were. We counted the plants per foot where we planted those seeds to see. So as you can see here on the top left corner, we've got the 511s, which is the 600 seed count, and we planted those at the 4, 5, and 6 miles an hour from the blue, orange, and the gray bars. You can see the number inside of there, which is 3.9 plants per foot at 4 miles an hour, which is ideal. That's exactly our target stand of 4 plants per foot that we're shooting for. Okay, as you see, we get lower as the speed got faster, down to 2.4 at 5 miles an hour and 1.6 at 6 miles an hour. As you look below there on the bottom left corner with the 511s at 3 seed per foot, we were comparing, we plant a lot of peanuts on twin row versus a single row pattern. Therefore, that cuts our seeding rate in half. And we could maintain a pretty consistent seed flow when you cut that seed in half through these new V-Drive meters. So there at 5 and 6 miles an hour, it could still maintain right at 4 plants per foot as our final stand count. Now, Looking to the top right, the AT 9899 is a Spanish variety, which is extremely smaller seed size. There's 1,036 seed per pound. We planted that at the same seeding rate on speeds as 4, 5, and 6 miles an hour. You can see there our stand counts around 3.2, 3.5, and 3.0. So pretty consistent there throughout those different speeds there with that smaller seed size. And then obviously at the 3 seed per foot at 5 and 6 miles an hour in the bottom right corner, you can see that was just as consistent there, even with half the seed. So there wasn't a difficulty in when we went to the 1,000 seed per foot, 1,000 count seed per pound for that smaller meter to handle. It's those larger seed that would bridge up through this area right here, the way that it feeds through there going to the seed tube, and that created our difficulty. So as we look at our yield data from that, as we focus in on the 511s, which are the top right corner, that was our larger seeded variety, runner type variety at 600 seed per pound. You can see it 4, 5, and 6 miles an hour. Statistically, there wasn't a difference in our yields between 4 and 5 miles an hour. As you saw that data from the monitor, the screen, that it was pretty consistent, and our stand counts were not off as much. But as you got there to 6 miles an hour, we did see a statistical yield drag there, because we just physically didn't have the stand out there because we couldn't get that flow through that meter of those larger seed. But as you look at that, when we cut that flow in half to demonstrate planting twin rows with it, you can see at 5 and 6 miles an hour, the bottom left corner, that we were able to maintain a consistent yield with no statistical difference between them. As we look at the Spanish variety, the top right, the 1,036 seed count per pound, 4, 5, and 6 miles an hour were all consistent yields. Statistically, no difference there. So our biggest hindrance with this new type system is going with this bigger seed at high planting speeds. So that makes it a little more difficult to achieve our goal there with that, because of our uniform flow into that seed tube. So no problem if you're going to plant twin rows with it, but if you're going to plant single rows and big seed, you're just going to have to slow down and plant in that 4 mile an hour range to maintain uniform planting.